This little 4-channel Class D's got a weird fault. When we power it up, keeping the voltage nice and low to start with, we have good power supply PWM, got a main power LED with a little blue LED on the board that then goes to red. I don't know what that means, but let's check what we've got on the output terminals. Now the active terminals connected to the amplifier are here, 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 and here, because they're the bridge ones. So on all the active terminals, we don't have anything at all. No audio, no Class D switching remnants, and no DC. What's super weird is that we've got 20 volts DC on the negative speaker terminals. This is output side ground. We've got DC on output side ground. What? So the whole amplifier on this board is just this tiny little chip here. It's a fully integrated Class D 4-channel amplifier from Texas Instruments. This is a typical layout schematic from the datasheet, which can be found on Google. You can see here we've got the outputs A, B, C, and D. But what's really weird is how this is connected. You can see the output A actually goes to the speaker negative, and the speaker positive is actually connected through this little network here to PVDD. Now the DC on the speaker terminals does make sense because this is an amplifier using a single positive rail voltage. We've got our 3 main rail caps here and they are all connected in the same polarity. The single rail voltage of this amplifier with 12 volts input is about 41 volts. Because we have only a single positive rail, we need to have about half rail at all times on the speaker terminals in order for the sine wave to swing up to rail and then down to ground. It turns out this amplifier may not actually have a fault. I usually start off powering amplifiers at about 9.5 volts to keep the rail voltage low and safe on the bench in case there is a fault. However, in this case, this amplifier seems to need a bit more than 9.5 volts. We're going to go all up to 12 volts and only then do the relays by the speaker terminals click in. I'm powering it up now, probing the positive speaker terminal. Watch this. No DC on the terminal yet. Relays click in. Then we get half rail and the sine wave oscillating up to rail and down to ground. And that seems to be working on all 4 channels here. So with that in mind, let's have a look at the second one of these. So up at 12.7, and this one definitely has a fault. We check the channels, relays click in, channel 4, clean output, channel 3, clean output, channel 2, we have no DC offset on the speaker terminals. So something's wrong there, we should have half rail. And channel 1, we have 10 volts DC, which is not quite half rail, it's not enough. You see, without signal, channel 4, for example, which is working, should have 21 volts half rail DC. The first thing I noticed is this. We have some cut traces. That looks like it's been done in the factory. Sometimes a decision will be made, especially along the ground paths, that then once fitted in a vehicle turns out to actually not be optimal. So that looks like factory. I'm not going to touch that. We need to turn our attention to this chip and its inputs and outputs. So these 4 thick traces are our outputs from the chip that will have Class D switching on them before the filter network. So let's just check these for Class D switching. We've got switching on channel 4, switching on channel 3. Channel 2, we just have the 12 volts DC. Channel 1 has about 2 volts DC. So the 2 possibilities, either the fault is within the chip itself, in which case we'll just have to order a new one. These are very expensive as well. Or it's a problem with supply voltages leading to the chip for each of the channels. So let's check that first. So the external elements are pretty simple. The only thing that would really prevent Class D switching if there was an external fault would be, see this BST? This is bootstrap, and this just requires a capacitor from the switching output to BST. So if that capacitor's faulty, that would actually prevent Class D switching or cause a problem. Really, as long as this thing has ground reference and has PVDD and a working bootstrap capacitor, it should just start oscillating. So really, the only external components that would be causing this problem are like these 2 capacitors or these 2 diodes perhaps. So on the working channel, these diodes are supposed to have a drop of 460, and then obviously the other way around, we should just charge basically to infinite. On channel 2, we have the correct voltage drop and it charges infinitely the other way around as well. But on channel 1, that doesn't look good. 124, and the other way around, we still have the same readings. So something's failed, either the diode or we're just reading a low resistance in the chip because it's failed. Yeah, unfortunately with the diode removed, we still have our low resistance. There's only one more component that it could be. There's some little white filter caps here, and we do have that low resistance across this filter cap as well. But honestly, I think that's pretty unlikely. We could try removing it just to see. Yeah, even with that capacitor removed from circuit like that, it still has the low resistance. So is the chip. And when I say these are expensive, I feel like £23 with VAT included is quite a lot for a single part. Okay, we are looking good. Let's see if that solved the issue. So we're looking for Class D switching on these 2 channels, so let's power it up and see what it does. Oh, yeah, that looks good. It's a little bit off the scope screen. Let's zoom out. And Class D switching on that channel. Let's just check the other two because it's a brand new chip. 3 and 4. We're back in business, baby.